The next definition is butt joint, and we're going to talk about that. I think the definition is actually from SDI saying a butt joint is this when it's not this. But there's more to understanding what a butt joint is in terms of how you go about fabrication in a shop setting. So let's talk about that definition right now. Let's switch to the screen view. If you are enjoying this video, please click thumbs up or like, and also please consider subscribing to our channel. Let's move on to the rest of the video. Alright, so butt joint, intersection of members which are not mitered. Okay, so intersection of members which are not mitered, that is going to refer to frame construction, frame material, when you're fabricating a jamb, whether you're doing it or the factory is doing it. Now, there are certain intersections that are typically mitered, and there are certain intersections that are typically or always butt jointed. And the bottom line is the manufacturer's price lists actually will even mention the word mitered when it comes to manufacturing. Let's see if we can take a look or find an example of where that would be. I'm going to pull up the Seco price list. I know the Kalani price list many years ago always mentioned it, because what they're saying is you can actually make a head and a jamb go together two different ways. You can butt joint them or you can miter them. And they literally do call out, you know, a mitered sort of construction in the price list. So under a, yeah, this is great. In the price list, you see these different frame sections, and these are just unusual. Yeah, custom frame profiles. This version, this model here is a standard masonry style frame, but they've got all these different details where you can have shadow lines around the wall and whatnot. But at the end of the day, when you take these parts and put them together, you can butt them together or you can miter them. And the factory is literally calling out when you do this when they do this custom fabrication, they're going to put it onto a miter coal saw, and they're literally going to cut it on a miter. Let's take a look in terms of what a miter cold saw would look like. It is a quite industrial tool, and it is going to have a metal cutting, probably a very fine tooth blade, and that it's going to be able to cut through ferrous-based metal. So here could be possibly an example of it. And you'll know a cold saw when you see this much longer handle on it. And actually, let's try these guys. Yeah. Let's see if Trick Tools. I've not bought anything from them yet, but it's happening. What I'm going to be buying from these guys is a wet horizontal bandsaw. But anyway, a miter coal saw, I'm sure they've got something here. Yeah, yep. Yeah, this is really typical that you're going to see in a hollow metal shop. So since we're spending the owner's money, let's look at the $12,000 version. This is a Dake Super Technics semi-automatic coal saw. So a tool like this is going to be really common for you to put a piece of jamb material into and make a really nice cut. So tools like this are going to give you a really clean cut coming out of, yeah, you put your jamb material right through there. Now, what's important about this concept is this is the right type of tool, not the tool. But you can cut obviously straight, or you can do a 90-degree miter left and a 45-degree right. The bottom line is you can miter on this. Now, when you are doing hollow metal work, you may have the ability to just simply butt something together. Now, if you're doing almost all intersections, let's just draw some. You know what, let's take a look. Yeah, let's do this. Technical manual. Oh, great. Yeah, this is what I'm looking for. So, in a typical opening, you've got this type of intersection where you've got two pieces that are touching each other. Sometimes they're, you know, linear at a 90-degree angle. Sometimes they're at 45 or unusual angles, and sometimes they're curved. But the bottom line is, this is an intersection type. That's an intersection type. That's an intersection type. These circles are intersection types. And as you stare at this side light frame with a transom is a great example. You can butt joint this, or you can miter this. You can butt joint this, but you can't miter this. So a T intersection is what is going to be butt jointed. On the outside of the frame, here or here, you're going to want to miter that. And because of how the metal is shaped, okay, cross section, if we're just looking at it that way, I suppose. But if you look at it in the back of the frame, if you look at the throat of the frame, it's going to kind of look like that. Your half-inch return. The bottom line is, if you were to take this piece and rather than miter it and butt it, looking at the jamb this way is what we're looking at here, you would literally have to take and cut all of this back if you butt jointed that, because otherwise your wall material is not going to fit inside of there. So doing a butt joint up here is really not ideal. You can do it, it can be done, you can weld right on this line here, but you've got a lot of extra work to cut all of this out back here. And the other problem with that is you don't get a really nice margin or a tight margin in these areas here where the stop and the rabbets are when you butt joint them together, because you've got to cut out, you know, part of the stop to get that to fit together on, in this case, the header. So you won't get a really tight joint there. But when you take a straight piece of section and you miter it on a 45, you're going to get an absolute perfect seam when you bring those two pieces together. And what the factory will do is what's called a full depth weld, where they, on the inside of the throat, they literally run a bead continuously on the inside of both of these faces and the intersection back here, and then back up the other side. And then, you know, using basic math, you can figure out, you know, what the distance is of the hypotenuse compared to what this length is. So this would be 2 squared plus 2 squared equal a squared plus b squared equals c squared. So you could figure out that there's more length or more surface area when you're full depth welding a miter. So you get a lot more weld than you would otherwise. And it would be argued that because of that you get a stronger frame assembly, I suppose. Plus, they're also full depth welding the inside of the frame as well. It's just not mitering it and then welding the face and grinding it smooth. The inside of the throat is all welded as well. Okay. So a butt joint is going to be an intersection where you can't or are not mitering it. So it is actually an elegant way to define it. But a butt joint is going to be a T intersection. When you have two intersecting members that form a T, or, well, it would just be impractical to miter any of this. I mean, it would just be really impractical to miter this. I'm not even sure how you would do it. So a butt joint is really typical. And when you take a strike mullion like this, all that you have to do is, when you have your jamb and you're looking at it, okay, all you have to do is notch this back. You make all of this go away, and you would on both sides, because that mullion is shaped, that strike mullion is shaped like this, and all you're doing is notching part of the stop and soffit away on both sides, and then you bring that piece right up tight and you square that with a good corner square, and you'll tack weld it here. And you'll do the same down here. This is all butt welded. This is a butt intersection. So when you're doing a miter, it's going to end up being a 45 degree. When you have a 90 degree intersection material, but a 45 degree angle is more practical. But when you've got two pieces that you are meeting the intersection, not at the outside edge, and actually that is a good, well, not really, because it would be very impractical to try to miter a sill section. So between headers and jambs, going to be mitered. Between sills and jambs, going to be butted. Mullion bar up here, that's going to be butted with your mullion, your strike mullion and whatnot. So you can make borrowed lights where you butt it all together, and people will butt joint them together when you don't have the ability to do a miter. And that would be more like a chop saw. So Milwaukee, Delta, DeWalt, everyone's going to have a chop saw. They take abrasive blades, and you know, most shops don't end up spending the money on a cold saw because of the cost. And chop saws like this, they're at your local home improvement store generally. So the downside of these is there are probably those that miter, but you're not going to keep, you wouldn't, actually this will miter. You can see that it will miter in the back there. You're not going to be able to trust this to give you a cut using friction, heat, to give you a true 90 degree throughout the entire height. Plus, these don't work because you don't have the height. You could miter something that's probably 3-inch tall, but you won't get a standard jam depth turned on its end. And plus, hollow metal frames are so thin to begin with, this would never work. So this kind of thing, it might be different if you were trying to compound cut it, I suppose, but this is going to be a butt cut every time. So shops that have only a chop saw like this, yeah, they're going to butt jams together, and they're going to have to do a lot of extra work to get that intersection to be nice and tight and clean. Masons don't like those butt joints. They can tell when it wasn't miter cut, you know, and that's just the bottom line. So if it's jam work, you're going to want to be mitering them. You know, and a butt joint does work. Oh, the other problem with a butt joint on like a jam or a borrowed light is after you make the modification to the jam, let's see, this is just the 2-inch face of the frame, and then you've got your 5/8 stop. After you cut that, and you'll cut this back, you're going to take your header and bring it in here. That's supposed to be a header. This is all open here. You have to have like a 1/2 inch, an angle that's like 1/2 by 1/2 to tuck it in here and spot weld it so you can close off the top of the frame. Here is what you end up having to do. So it's not ideal at all. And plus the throat opening up there becomes smaller than 5 3/4 or 5 7/8. So if you're a hollow metal shop, I would, and you do a lot of this, I would keep your eyes open for a proper cold saw that can cut on a miter reliably all the time, because that's how fab shops and large manufacturers, they're going to have that ability to cut that material. That's how it's going to be. Okay, now the next definition is going to be butted frame. Yeah, okay. So let's talk about a butted frame next. Thank you for watching, and if you've enjoyed this video, please click thumbs up. Please subscribe and maybe even send the video to someone that you know. Thank you.